Okay, welcome to section 6.4, rectangles. We're still working actually with parallelograms, believe it or not, but a specific type of parallelogram. Okay, so rectangle. Um, and you may have your own idea of what a definition of a rectangle is, but now we're going to get into the mathematically formal definition of rectangle. So first of all, rectangle is not just a shape where both pairs of opposite sides are congruent and something like, where you kind of think of these two sides are the same and those two sides are the same, but they're not all four the same because it's a square. Actually, it's much simpler than that. A rectangle is, first of all, a parallelogram. Okay, it's first of all a parallelogram, and it's a parallelogram with four right angles. That's it. Okay, so a parallelogram with four right angles. Now, on your test, you're going to be asked to define what a parallelogram, what a rectangle is. And some of you will say stuff with like congruent sides, whatever it is. No, that's it. All it is a rectangle with four right angles. Now, one of the things that's going to kind of get difficult in this chapter is, that does get difficult, is keeping all of it straight. So you have to remember that by definition, it is a parallelogram. Okay, it is a parallelogram by definition. That didn't show up very well, did it? Whoa, that makes it go away. Okay, don't want to do that. A rectangle is a parallelogram by definition. So you have all the properties of parallelograms. First of all, by definition, by its actual definition, you have that all four angles are congruent. Okay, or it means all four angles are right angles. You have opposite sides are parallel and congruent. That is by parallelograms definition. You have opposite angles, or by properties. You have opposite angles are congruent. You have consecutive angles are supplementary. You have the diagonals bisect each other. Those are those four properties. You also have the sense that one, if you have one diagonal, you have two congruent triangles as well. And then you have one new property for a rectangle, and that is that the diagonals are congruent. Now to kind of go through that real quick, here's what you have to piece together. So let's just call this A, B, C, D. Here's our rectangle. And in our rectangle, if I draw on the diagonal, this side's congruent to this side, this side's congruent to this side, right angle, or really, again, it's a parallelogram, so you already know that both pairs, if you draw one diagonal, the two triangles are congruent. The key to this, though, is if I draw the diagonal this way, or, and I'll do this in a different color, like a light blue, hopefully it stands out enough. And there we go. If I draw the diagonal that way, I get, it's still 1, 2, or single mark, double mark, right angle, single mark, double mark, right angle. So whatever happens, this rectangle, when it gets cut in half, the two triangles are always congruent. Unlike on a parallelogram, okay, those two triangles are congruent, but they're definitely not congruent if I draw it in this way. These two triangles are not the same as those. Whereas with a rectangle, if I draw the triangles in that direction, or I draw them in this direction, those two triangles, all four of those triangles are congruent. So that means that the two diagonals then also have to be congruent. So yeah, that's our theorem. And again, hopefully it's pretty evident that if you have a rectangle, so if a parallelogram is a rectangle, then its diagonals are congruent. Okay, so using that, first problem. Quadrilateral EFGH is a rectangle. If GH is 6 feet and FH is 15 feet, find GJ. Okay, so first of all, let's mark what we know. Okay, we know we have a rectangle. Let's see, GH is 6. So here's GH, it's 6. Which means FE is 6, because remember, in a rectangle, the opposite sides are congruent because it's a parallelogram. And FH is 15. The question is, what is GJ? Okay. Well, there's a little bit of the book kind of being difficult here, because we don't need to know all this stuff they told us. We don't need to know that GH is 6. Here's all we really need to know. This guy's a rectangle. If you're a rectangle, your diagonals are congruent. Okay, so if FH is 15, that means GE is 15. Okay, that's the theorem because it's a rectangle. Now because it's a rectangle, it's also a parallelogram. And one of our properties, and that does say parallelogram, and one of our properties of a parallelogram is the diagonals bisect each other. In fact, on a rectangle, since the diagonals, are congruent, they bisect each other into 4 congruent segments. So if this is 15, this is 7.5, this is 7.5, this is 7.5, this is 7.5. Hey, that's what I know. It's 7.5 feet. That's GJ. Okay. Next, quadrilateral RSTU is a rectangle if it is. Okay. If measure of angle RTU equals 8x plus 4 and measure of angle SUR equals 3x minus 2, then find x. So again, it helps this one to draw what we know. So we know it's a rectangle, okay, which means we have right angle, right angle, right angle, right angle. We also know that this is a parallelogram, so parallel, parallel, so congruent, congruent, and congruent, congruent, and congruent, congruent, and congruent, congruent, by alternate interior angles. So we have a bunch of congruent angles in here, a bunch of right angles. So let's see what they gave us. Well, they gave us that RTU. Let's see, which one's RTU? Ah, well, here is RTU. RTU, right there. That one is, they said it was 8x plus 4. Which means this is also 8x plus 4. Yeah, 8x plus 4. Let's see. Sorry, my eyes are itching me. I'm probably bumping the microphone like crazy right now. Okay. And then SUR is 3x minus 2. It means this is 3x minus 2 here as well. Well, what that also means is this is 3x minus 2, and this is 3x minus 2. Oh, guess what? Those two angles together make a right angle. So 3x minus 2 plus 8x plus 4 has to equal 90 degrees. And now we just kind of put our stuff together. 3x plus 8x is 11x. Negative 2 plus 4 is plus 2 equals 90. Subtract 2. 11x equals 88. Divide by 11. Divide by 11. X is 8. Okay. So yeah, there are all kinds of crazy congruent pairs of angles in this drawing as well. All right, so that's I mean, there's one more theorem here. If we want to prove that we have a rectangle, we can prove it by showing that the diagonals are congruent. So if your diagonals are congruent, you must have a rectangle. Okay. And then for homework tonight, okay, we have quadrilateral WXYZ with vertices at W, X, Y, and Z. Okay, so here's the thing you have. I have this rectangle here. I haven't plotted them out. I don't care to. I don't even need to. I just need to know that I have W, X, Y, and Z. Okay. They have these ordered pairs. W is at negative 2, 1. X is at negative 3, 1, negative 1, 3. Y is at 3, 1. And Z is at 2, negative 1. Again, I don't care where they're really at for this. I just know kind of roughly where they are. What I'm going to do now is I'm going to find the lengths of diagonals W, Y, and X, Z. And if they're congruent, okay, they are a parallel. It is a rectangle. So how am I going to find out what those lengths are? Distance formula. Whoops. If I could type. There we go. Distance formula. So you'll use the distance formula to find the lengths of those, and we'll discuss this in class. So if you have any questions, come on in. We'll go over it, and otherwise I'll see you in class the next day. Thanks.